Hello everyone, this is Darsh Chitalia. Welcome to my channel Darshonium. In today's video, we'll be learning about electronic configurations. So let us define what is electronic configurations. It is defined as the distribution of electrons into the orbitals of an atom. Now, these orbitals around the nucleus can be represented in two ways. First, by using numbers, that is, the very first orbit after the nucleus is numbered as 1. The next one is number 2 and so on and so forth, 3, 4, 5, 6, 7 and so on and so forth. Another method of representation is by using alphabets. The very first orbit is represented by using the alphabet K. Second one is represented as L, then M, N, O, P and so on and so forth. Now, these orbits can hold only a specific number of electrons. So the maximum number of electrons that an orbit can hold can be calculated by using the following formula. The formula is 2n square, where n represents the number of orbit that you want to find out. For example, let us find out how many electrons can the first orbit hold. The first orbit can hold 2 into 1 square, which is 2 into 1, which is 2. So the first orbit can hold 2 electrons. Now let us calculate how many electrons second orbit can hold. So now it will be 2 into 2 square. 2 square is 4. So 2 into 4 is 8. So the second orbit can hold only 8 electrons. Similarly, we can calculate for third, which is 2 into 3 square. 3 square is 9. So 2 into 9 is 18. So the third orbit can hold 18 electrons and the fourth orbit can hold 32 electrons. Now we will take some examples. We will take some examples of which we will find out the electronic configurations and their diagrams. So the electronic configurations would be this side and the diagrams would appear on this side. Let us take example of the very first element, which is hydrogen. The atomic number of hydrogen is 1. So it has 1 electron. The first orbit can hold up till 2 electrons. So the electronic configuration of hydrogen would be in bracket 1. The diagram you can see over here. The next element is helium. Helium has 2 electrons. So the electronic configuration will be in bracket 2 and the diagram is on the screen. Now the third element is lithium. So the atomic number is 3. Now the electronic configuration for lithium will be in the first orbit it can hold only up till 2 electrons. So after filling up the first orbit, the third electron will move into the next orbit. So the electronic configuration then becomes 2, 1. Let us take one more example. We will take example of carbon. The carbon has atomic number 6. So now what will be its electronic configuration? The first orbit can hold 2 electrons. So now 2 are filled in the first electron. Remaining 4 will be in the next orbit, which is the second orbit. So the configuration becomes 2, 4. As you can see, the diagram is on the next side. Now we will take the example of sodium. The electronic configuration of sodium. Atomic number is 11. So the first orbit will hold 2 electrons. Remaining 9 electrons, out of which the second orbit can hold only up till 8 electrons. So the 1 electron which is remaining will move into the third orbit. So the configuration becomes 2, 8, 1. Now let us take example of silicon. Silicon has atomic number 14. So the electronic configuration will become 2, 8, 4. One more example would be of argon. The argon has atomic number 18. So it has 18 electrons. So the configuration will be first orbit will have 2 electrons, second orbit will have 8 electrons and the third orbit will also have 8 electrons. So the configuration will become 2, 8, 8. Now let us take last and final example. We will take the example of potassium. The potassium has atomic number 19. Now, according to the rule, the electronic configuration will be 2, 8, 9, right? But this is not true. The actual answer for it is 2, 8, 8, 1. Now why is this? This I will be explaining in my next video. So this was a very basic video of how to write the electronic configuration of the elements. I hope every one of you liked this video. If you liked my video, please smash out the like button. If you have any suggestion or any queries, please comment right below. Share this video with all your friends. Thank you for giving me all your time. I hope everyone enjoyed. सब लोग मजे करो.